Question 3, we have an ice hockey player with a puck. The puck is like this disc thing. Mass of 0.16 kilograms, moving horizontally across the surface. This is the speed. Calculate the magnitude of the momentum. So that one, given the fact that there's speed and mass both readily available, we can pretty easily calculate the momentum. So my formula for momentum is mass times velocity. So I just write velocity like that. And my mass is 0.16 kilograms multiplied by 15 meters per second. Put that into my calculator and I get 2.4 kilogram meters per second as my momentum. 1 mark for the work, other mark for the answer with the units. That was pretty straightforward. Then for this next one's a little bit trickier, and it's largely to do with the way that the question is phrased. So we have the hockey player, he strikes the disc with his stick, and obviously the direction of the disc is going to change. Therefore, the momentum of the disc changes, since momentum is a vector quantity. So the disc gains momentum of 3 kilograms meters per second, 45 degrees from the horizontal, which was the original direction of travel. Now, keep in mind, it gains this momentum. It doesn't gain momentum such that this is its final momentum. It is not its final momentum. It is the amount that is given to it such that it now has a new unknown momentum. So for question I, when it's asking what is the impulse, remember that impulse is the change in momentum. So you have an old momentum and then you have a new momentum, and the difference between the two, that's your impulse. So when I am given 3 kilogram meters per second, that's what I'm changing from my old one in order to have a new one. So that is the impulse. So I just write it in here, no calculation needed, but rather understanding of the situation. Oops. And the direction, well, it was given 45 degrees from the original. Now we are asked to draw a vector diagram to scale. So keep in mind, if it's a scale diagram, you have to specify what your scale is going to be. So if my initial momentum is 2.4 kilograms meters per second, then I need a scale that is going to show that in my picture. So I could say, for example, 1 centimeter equals 1 kilogram meter per second. That could be a reasonable scale. So when you draw it, your initial momentum is going to go towards the right, because that's your initial travel. And you could call it PI, or you could label it 0.4 kilograms meters per second. And then we have our impulse. So this is the amount that you are adding onto your initial amount. And this one is 3 centimeters. Now I'm doing this on my iPad, so my scale is not great, but you should be using your ruler. So my impulse, which is 3 kilogram meters per second, and this angle at which I am drawing my vector is 45 degrees. And so my initial momentum plus my impulse gives me my final momentum, which is this guy up here. I'm going to call it PF. And then how do I know how long it is? Well, because my diagram is to scale, I'm just going to take my ruler. I'm going to measure how many centimeters this line is. Because 1 centimeter is 1 kilogram meter per second, my line is about 5 centimeters long. So that means this is about 5 kilogram meter per second or so. The mark scheme allows anything between 4.8 and 5.2. And then when I measure my angle, it should be roughly, 25, 26 degrees. The mark scheme allows anything between 22 and 28. So again, this is why it's so important to clearly label your scale, not just for the examiner, but for yourself. And to be neat, use a ruler, use a protractor, make sure you can get the most accurate measurements possible. Now, if you are confused as to why we drew the vectors in this order, remember that vector addition, you always want to follow your vectors that you're adding together with your finger, tip to tail. So if I start here and I end here, my arrows need to agree with that, and then my resultant goes from start to finish. Now, why is impulse not the resultant? Well, it comes from the definition of impulse, right? Impulse is the change in my momentum. That means I am subtracting my final momentum from my initial momentum. So if I want my final momentum on its own, that means I gotta bring my initial momentum vector over to the other side. And there you have the vector addition written in equation form. So you have your vector, this orange vector plus your gray vector, or addition is, it can happen in any order. So you can have the gray vector plus the orange vector, again, as long as you can follow with your finger in the direction of the arrows from one start to the end. And then your resultant goes from beginning to end.